Guys, welcome to technical drawing class. Still on locus of a point. I'll be treating the topic cycloid. Now look at this question over here. If you have a question like this that says draw a circle of diameter 60 mm which rolls without slipping along a straight path or a line. What you need to understand by cycloid is that a cycloid is a curve produced by a point on the circumference of a circle which rolls without slipping along a straight path or line. Example, if a wheel of a motorcycle is marked with a white point at the bottom and made to roll along a straight line on a road or a line. Remember this wheel that you have our motorcycles or car uses. One will notice how the mark moves, and at the end of the series of rotation, a cycloidal curve is produced or formed. That is how you see it will move in a form like this. I want to show you an illustration. If you have your wheel, your car tire moving on a straight line, it will move somehow like this way, just because I'm trying to be careful, but let me do it better here. It will move like this. So that is how it will move. You discover that there is something, a cycloidal form will be formed this way. That's a cycloid. Now we want to use this as an example to teach you how to construct a cycloid. So how do you construct a cycloid? Using this question. The question says that draw a circle of diameter, it can be a wheel of diameter 60 mm which rolls without slipping along a straight path of a line, or a straight path or a line, along a straight path, or it should be or a line, along a straight path or a line. So what do? The first thing is that you take your devices, your compass, and what do? You measure out the diameter. The diameter is 60, so you measure out the radius, which should be 30. You can see what I'm doing. 30. You can check to avoid zero error. So you draw it this way. Can you see it? You just pick a point as I picked, then you draw. So this is what you do. Then after you've done that, you divide this circle into 12 equal parts. You divide your circle into 12 equal parts. So you can use your set square to do that, because this is the middle point of your circle, which you must note. So you divide it into 12 equal parts. Your set square and your t-square, they are devices or equipment, instruments you must not play with. 12 equal parts, t dividing, now you can use your compass if you wish. You know that the diameter is still 60, and you can use your set square to divide. You use your 60 and your 30, but I prefer using compass to have an accurate measurement. So that is why I'm using my compass. Now if you bring this one, which if you want to use your set square, said you will use your 30, 60. This is your 30, this is your 60. Now let me just use that to prove that it's still the same. You see I'm using my 30 this way. It must touch this point and this point. Can you see that? Now if you turn it to the other side using your 30, again it must touch this point and this other point. Then if you turn your to the other side, it must touch this point, that's your 60 now, and this point. And if you use your 60 this way, you must touch this point and this other point. Now you can now start labeling from this point, but before this you extend this your middle line, which is 0. This your center point, is you label it 0, and you extend your middle line. Now from that you can draw a perpendicular line, an horizontal line to this perpendicular line, which you label from this place 0, 1, 2, all these your points, 3, 4, 5, 6, 7, 8, 9. This point is 9. This is point 10. This is point 11. Now you draw an horizontal or a perpendicular line to this. This is horizontal to this perpendicular line, and this is perpendicular to this line also. Now, so what do you do? Now, after you've done this, the next thing is that if you are starting from this middle point, you can mark. Therefore, if you are not given a point that starts from point P, or maybe a point on your straight line which is given from point P, you have A to B. If you are given something like that, then you have to mark A to B on this. But if you are not given something like that, you can start from this point to show how it rolls, how it revolves, like what you have here, to show how it revolves. Now, what am I going to do now? I'm going to divide. I'm going to start from this point and show how it revolves. Now, I'm going to use my compass and measure this radius, this same radius, and I'm going to divide my lines from the middle. That's my middle line. I'm measuring same radius. Now I start from here. I move, that is 0, that is 1, because this first point is 0, so this is 1, this point is 1, so this first point now I took it as my 0, so this is my 0. Let me take this point. This is the first point, this is the second point. Now I move that way on this same line. This is the third point, this is the fourth point, There's a fifth point. There's a sixth point. 7 point. Hope you see the way I actually mark them out. Now, from that drawing, you will discover I want to show you a diagram of one of those drawings. So you discover that from that first point where I start marking, just like what you have here, you can see from this diagram, I'm going to draw something similar. So you start from this point. If you are starting from this point, if you start from this point, you have 1, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you still have to have another one, which is, you still have to extend that line. Sorry, I may not be able to show you perfectly because of these lines, but if you start from this place, which is your C0, you made this one your C1, your C2, C3, C4, C5, C6, C7, C8, C9, C10, and this one will be what? C11. So you might have something very close. So what do? You take your measurement, which is the same radius. But before you do that, you have divided these lines, you need to draw them out. You draw them out, you show it. You draw this line, you show all this by, you extend all these, these divisions of line. As you start from 0, you do that of 1, that of 11, but that of 111 should be the same. So you just show us from this point, it should be the same. You move to that of 10. That of 10 and 10 and 2 should also be the same. So you show us, we need to see it. You move to that of 4 and 8. It also should be the same. 4 and 8 should be the same. So you show us. Then you move to 5 and 7. 5 and 7 should be the same. And you show it to us also. 5 and 7. Then you have 6. Now, you discover these lines now. So on this, you use your compass. Now, you measure that same radius, which is 30, for the diameter. So this is the first circle. You move to the second circle, which is this. And you start by showing. So the first point is going to be from this 0. The second point is going to be, as we see now. Don't forget, you must be sure that you are using the same diameter. If not, you are not going to have an accurate value. Okay. Okay, that's a mistake, so you have to be careful. You have to measure again. It must be an accurate value. You move to the next point. Which is this. You see, as you show those points, you can start taking note of your intersection. So the first one you have here, you have this point, this is the second point, and this is the third point. So you move to the next one, make sure it's still the same diameter. Be sure that you are using the same radius. The radius must not change. You move to the third point, this is the third point. Now you note the third point, first, second, this is the third point. Now, there is another thing I actually omitted, which I think I should do now. You will discover that this line, I did not draw them, the intersections of this line. But let me draw them now. This point, you discover this is point 1, this is your point 2. This is your point 3. This is your point 4. This is your point 5. This is your point 6. 0.7, 0 point, the next point, that's the perpendicular. You have to draw the perpendicular for each of them. Now, so you know this is the first point, this is the second point, so this is the third point, this third point, this is the third point where your circle actually meets. You see, it's concise with the perpendicular. So you move, you pick that same radius. I'm trying to pick that radius, you will see. Okay, it's that same radius, as you can see. Now you move, you've done for this, you've done for 3, so you move to 4. Do you see that? So you draw. Now you note, this is your third point, this should be your fourth point. Then you go to the left point. Using that same radius. Discover that the next point is here. You notice your point, so you have your point 1, 2, 3, 4, 5, 6. So the next point is here. You go to the next point. cross check. Your radius must be equal. That's 0.6. And you draw again. Then your next point this is your 6th point. The next point should be here. Do you see that? Then from that now you take the next diagram, you continue from point 7. Point 7, your point 7 is here. So at this point, then you check the next one, cross check again. That's your point 8. Now you begin to notice a flow. It begins to come. This is your next point. This should be your next point. This point should be your next point. From your point 7, you go for point 8, point 9. Point 9. You see? Your point 8 should be somewhere here. Your point 9 is somewhere here. Then you move to point 10. So we continue from here. You see this is 12. I'm still drawing using this point 10, using radius, you confirmed. This is point 11. Then you have your point 12. From this other point, you can see that this is the 12. You start from this point 2, this is, and this is where the next intercept is. And for this point, the next intercept is here also. Just like what you have in that other one, the next intercept is here. Then for this one, there is another intercept here, which you have over here. Then you can see that you have a curve part this way, which I will use to bring out to you so that you can see. So this is how you draw your cycloid. So you trace out this point, and they must actually meet. You trace them out and you draw out your cycloid. So for this, there is an intercept here. For this 8, you have an intercept here. For this 9, you have an intercept here. For this 10, you have an intercept here. So you have an intercept for each of them. 12, this is 12, this is 11, this is 10, this is 9, this is 8, and then this is for 8. Yes, and then this should be for 7. This point should be for 7. Show the point by using your French curve. I'm using this as my French curve, and I'm going to draw them out one by one now. Where's my eraser? It must be a curve. So hope you can see the cycloid. That is how you draw a cycloid. So you can be given a question that a wheel, let me see questions, let me just see examples of questions that you can be given. Let me read them out to you. You can be given a question to actually draw a cycloid, or draw, they can give you a questions and say, and just ask you that I want to read one of the questions you might likely see. If in this kind of question you can be told to just, you can see a question like a wheel of 70 mm or 80 mm rolls along or rolls without slipping along a straight path. Plot the locus of point P on the rim of the wheel and initially with contact with the path. When the wheel makes half a revolution along the path, it's still cycloid. It's still what they are actually asking you the same question. But in this place, you have to check if it's a complete revolution, if it's half a revolution. If it is half a revolution, this is a complete revolution. If it is half a revolution, it means you are going to stop at the middle of that's 6. It's not going to be 12. So you have to check if it's a complete revolution and if it's not an incomplete revolution. So you have to know what kind of revolution it is. So that's how they ask you about a cycloid. So that is on cycloid. And then till we meet next class, remain, stay connected.